Good morning, everyone. In today's lecture, we are going to find the Laplace transform of some important signals. So, the first one is unit impulse signal. So, x of t is denoted by delta of t, or x of t is equals to delta of t. So if we'll find the Laplace transform of it, minus infinite to infinite delta t. Now there's an important property of impulse function that it is defined at only at one point, at t equals to 0, which is in the bracket, and 0 elsewhere. So in this signal we will put t equals to 0, and at that point this delta t is 1. So we can say that x of s is equivalent to minus infinite to infinite delta t e raised to the power 0 dt, because t is equals to 0. So we can say x of s is equals to minus infinite to infinite delta t dt. Now there is another property of impulse function, that's integration, or you can say the area under impulse function is equals to 1. So we can say that the Laplace transform of delta t is 1. Now the only thing which is not with us now is the region of convergence of it. So the region of convergence when a signal is defined is that ROC is equals to, this signal is defined for all s, or you can say in terms of the notation it is defined at all s, means entire s plane this signal is defined. Now another important signal is unit step function. As the name indicate, this signal is in the form of a impulse step. So zero, it's 1, this is ut, and then t. So this is 0, and then it raises in a step, and it up to infinite in time the amplitude is always equals to 1. So in terms of notation, I explained in the previous lecture also that ut is equals to 1 for t greater than equals to 0 and 0 elsewhere. So now if we need to find the Laplace transform of ut, then its Laplace transform of ut is equals to your x of s equals to 0 to infinite, it's 1 dt. When you will find the integration of it, it will be x of s equals to minus 1 upon s into, and the limits are 0 to infinite. So now when you will put the upper limit, when t is equals to infinite, e raised to the power minus s infinite must be equals to 0 in order for this signal to provide us an answer, or you can say in order for this to converge at some points. And for that you need to have s greater than equals to greater than 0. So xs is equals to 1 upon s. When you will put the lower limit, it will be e raised to the power 0, and there will be a minus before you insert the lower limit, so it will be positive, and the condition is s greater than 0. So in this way you will find the Laplace transform of unit step signal. So next one is your Laplace transform of cosine signal. So let's say cos at into ut. So if you are finding this, then x of s will be equals to, this 0 to infinite will come from ut, and then cos at dt. Now if you will apply the normal integration here, then the answer will be very long. So you need to use the identities with respect to cos at. So if you remember that cos at can be written as e raised to the power j at plus e raised to the power j at divided by 2. If there will be a sin at, then it will be replaced by e raised to the power j at minus e raised to the power minus j at divided by 2j. Then put this values there. So x of s will be equals to 1 by 2, 0 to infinite, e raised to the power, this 1 by 2 comes here due to this, j at so if you open it, x of s equals to 1 by 2 0 to infinite. Always try to make your common terms with e raised to the power this and e raised to the power something in this way, that you have a form of s plus something or s minus something. So if I take common between this and this, it will be e raised to the power minus s. So whatever you have in multiplication with s, you have to take that common. So I have taken minus 1 common. So it will be s minus j at, sorry, at, t will come outside, j a t, and then plus e raised to the power minus s plus j a t and dt. So if you will take the integration of it, then it will be 1 by 2 e raised to the power minus s minus j a t divided by and this is and the limits of integration for both of them are 0 to infinite. Now here you need to remember one thing, J is a factor which brings a phase shift. So the region of convergence will be decided by S here. So when you will put the limits, the upper limits here, so it will be something like S minus JA infinite, and for the another one it is e raised to the power minus S plus JA infinite. So we have to take into account only the real part. So in order for this to be equals to 0, and in order for this to be equals to 0, we must have a condition that S must be greater than 0. So we can say for both of them that x of S is equals to 1 by 2. Upper limit will be solved due to this, that it is 0. So you can say 0 minus e raised to the power 0 divided by and then minus 0 minus which I solve further, then it will be equals to sorry for that, x of S equals to 1 by 2 and with the region of convergence S greater than 0. So this is one by 2 should take the LCM, and this will be S square minus J square A square with a condition imposed of ROC S greater than 0. So you can say that this will cancel out with this. Okay, so you can say equals to so it is 1 by 2 into 2s divided by s square plus a square with s greater than 0. 2 will cancel with 2 also. So the final answer which we have is x of s equals to s upon s square plus a square for s greater than equals to s is greater than 0. At this point I want you to try this. I'll solve this question in the next video. What will be the Laplace transform of sine at ut? Okay, so thank you for watching the video, and please ask any questions. Please like, subscribe my channel, and if you have any queries, put it on the comment box. Thank you. Answer equals to 1. The problem is in the lower limit now. Means when you put t equals to minus infinite. So when your t is equals to minus infinite, then e raised to the power minus s plus a, there will be a minus infinite, this. So in order for this to be equals to 0, so if this is not equals to 0, then we will not be able to find a finite answer. So in order for this to be 0, this should be equals to negative. Why? Because we must know at this point that e raised to the power minus infinite is equals to 0 and e raised to the power infinite equals to infinite. So in order to make sure that this is equals to this part is equals to negative, we must say that s plus a must be less than 0, then it will converge. So now for x's we have condition s plus a less than 0. So x of s will be equals to, with the condition that, or you can write it s less than minus a, or you can write it real s less than minus a. So any one of these will be used. Now if you represent it, now here one more thing which I want to highlight here is that if you see the excess of this is equals to 1 upon s plus a, and excess which we find out here also, it is also equals to s plus a. That means for both of them, both the signal e raised to the power minus at ut and minus e raised to the power minus at u of minus t, they have the same Laplace transform. The only difference is they have different region of convergence. So if I plot it on a s plane, so it's s plane of ROC, then so this is sigma, this is sigma, this is j omega. Now the point is minus a again, the only difference is now the region of convergence now is less than this. So in this way you will do the Laplace transform of these two signals. Now at this point I want you to try two more signals with a similar form. So you will have x of t equals to e raised to the power at ut, and x of t e raised to the power at u of minus t. And you will I'll solve this in my next video. So it's basically kind of homework for you, and you can give me comments on the basis of it on this. Now in the next lecture I'll find out the Laplace transform of important signals like unit impulse signal, unit step function, sine and cosine signals. Thank you.